let's reduce the minus by multiplying through by minus sign. Minus times minus 4p will give you 4p plus 2q minus r is equal to 13. This is equation 2. Now in our question we have used x minus 1 to establish the first equation. We have used x plus 2 to establish the second equation. If you look at our equation, we have 3 constants, so definitely we need 3 equations. Now they went further to say that the remainders, okay, if x plus 1 is a factor of this, so x plus 1 they said is a factor. Remember factor theorem. So what will happen here again is to bring in x plus 1. This time around is a factor, so that means x plus 1 will be 0, so that x will become minus 1. So you put it in the polynomial again. Minus 1 is equal to p minus 1 bracket minus 1 cube plus p bracket minus 1 squared plus q bracket minus 1 plus r. This time around, since we were told that it's a factor, so it will leave no remainder, to be 0. So this one will be minus 1 cube is minus 1. Don't forget to multiply p minus 1 plus p minus 1 square is 1, then minus q plus r is equal to 0. If you open this bracket, you have minus p plus 1 plus p minus q plus r is equal to 0. If you take a closer look, you see that this is a minus p, this is a p, so 2 of them will cancel. So what I have here is minus q plus r. This one will go to the other side to be minus 1. This will be your equation 3. Now solving simultaneous equation, there are so many approaches to it, so just watch closely what I'm going to do. I have the option of reducing the terms. This is equation 1, this is equation 2, and this is equation 3. I can decide to remove p in these two equations and solve simultaneously, or I can decide to substitute one letter here in these two to solve simultaneously, and that is what I will do. So in this equation 3, I will make r the subject. R will be equal to q minus 1, equation 4. What I'm going to do, I will use a layman language here. I want you to put q minus 1 in place of r in equation 1 and 2. What this means that I'm going to replace r with q minus 1 in equation 1 and 2. So if you look at your equation 1, this is our equation 1. So I want to bring it closely. Equation 1 is 2p plus q plus r. So this r is going to become q minus 1. So I will write 2p plus r, let's see, plus q rather, then plus q minus r minus 1 is equal to 5. I've replaced r with q minus 1. So this equation will finally give us 2p plus 2q is equal to 6. Equation 5. Please keep identifying the equations. The next one, in equation 2, we're going to do the same thing. Our equation 2 is 4p plus 2q minus r. So this minus r is going to become q minus 1. So let's do that. So we have 4p and 2q. 4p plus 2q minus q minus 1. Please put it in the bracket. There is a minus sign attached to r. Minus sign is attached to r in equation 2. So you must put it in a bracket. So it's equal to 13. Now simplifying this, you have 4p plus 2q minus q plus 1 is equal to 13. So this is 4p plus q is equal to 12. Equation 6. I have 5 and 6 with just 2 variables, so I can solve them simultaneously. So I'm solving simultaneously. So bring them close. This is 2p plus 2q is equal to 6. This is 4p plus q is equal to 12. This is our equation 5 and 6. Now if you look at equation 5, I can reduce it by dividing through by 2. So this one becomes p plus q is equal to 3. Then this one becomes 4p plus q is equal to 12. So you use subtraction to kill q. So p minus 4p will give you minus 3p. 3 minus 12 will give you minus 9. So p becomes 3. Now you begin to call on those equations. That is why it is important to identify them with numbers. You can use any equation to get q. In equation, I want to use 5. This simplified 5. 3 plus q equal to 3. So q is 0. Now, same place here. I want to get r. Remember the equation that connected. Equation 4 is r is equal to q minus 1. R is equal to q minus 1, where q is 0. So r is minus 1. Therefore, our p is 3, our q is 0, and our r is minus 1. So what you will quickly do is to write the equation now that we have gotten them. The equation is from our answer. This is the equation. So we are going to write the equation out. Q of x is going to be, let's find the original equation. This is it. So q of x is going to be 3 minus 1, because our p is 3, x3 plus 3x squared plus this is gone completely, 0, then r is 1 minus 1. So the original function is 2x cubed plus 3x squared minus 1 cube of x. Now you go back to the question. Let's see what we have gotten. Find the values of p, q, r. We have gotten the values of p, q, and r. P is 3, q is 0, r is minus 1. Now using your result in A, factorize qx completely. Now if you want to factorize this completely, don't forget x plus 1 is a factor. X plus 1 is a factor, so you use your long division. This is 2x3 plus 3x squared minus 1, x plus 1. So x divide 2x cubed will give you 2x squared. You use it to multiply x plus 1. 2x squared times x will give you 2x cubed. 2x squared times 1 will give you 2x squared. You subtract your answer from the top. 2x cubed minus 2x cubed will give you 0. 3x squared minus 2x squared will give you x squared. Then minus 1 minus nothing is minus 1. So from this answer, you divide again. X into x squared will give you x. Then you use your answer here to multiply back. X times x is going to give you x squared. X times 1 is going to give you x. You subtract again. X squared minus x squared will give you 0. Now there is a position of x before minus 1, so nothing is there. 0 minus x will give you minus x. Then minus 1 minus nothing will give you minus 1. So here you go again. X divided by minus x will give you minus 1. Minus 1 times minus x will give you minus x. Minus 1 times minus 1 will give you minus 1. When you subtract, you have 0 and 0. If you don't get this 0, it means you are wrong along the line. So you have to check again. But I got my answer to be 2x squared plus x minus 1. So I factorize this quadratic. It's quadratic. If you break it, it's going to be plus 2 minus 1. 2x squared plus. So these are the factors. You factorize. This is 2x bracket. Factorize this 2. X plus 1. Between these 2 minus 1 is a factor. X plus 1. So this is going to be x plus 1 and 2x minus 1. Therefore, factors are x plus 1. I have another x plus 1. There is the first one here, so it's double, and 2x minus 1. So this is the answer to the question that says factorize completely. Now find the zeros of polynomial. Simply means equate the factors to 0 and get your answer. So the last question, C, zeros of polynomial implies x plus 1, x plus 1 and 2x minus 1 is equal to 0. So x is equals to minus 1 twice, or x is equal to 1 over 2. So these are the zeros of polynomial. That is finding the values of x. So we have come to the end, though it's large, but this is it. Question number 1 and submit. Thank you for watching.